Welcome to the Wheat Processing Lecture, a pre-course module for VM 101, Grain and Feed Mill Operations course. This e-learning web course was created by Dr. Cassie Jones, an assistant professor of feed technology in the Department of Grain Science and Industry at Kansas State University in Manhattan, Kansas. This course was made possible by FDA grant 1U54 FD 004333-01 to Iowa State University. By the end of this lecture, participants will be able to recognize components of wheat processing prior to receipt at feed mill, identify classes of wheat and wheat byproducts commonly used as animal feed ingredients, list food safety hazards associated with wheat and wheat byproducts, and identify specialized equipment used to process wheat and wheat byproducts. Wheat is ranked third among field crops in total acres planted, acres harvested, and gross farm receipts after corn and soybeans. However, total acres planted has dropped by 1/3 since its peak in 1981 due to increasing acreage from other field crops. Sometimes it is fed as a grain to livestock. For pigs, it is ground, and for cattle, it is steam flaked. However, wheat is primarily grown for human consumption and therefore not usually economical to feed to animals. The wheat milling process converts 70 to 75% of wheat to flour, which leaves 25 to 30% as wheat byproducts that are a common animal feedstuff throughout the country. The primary byproducts used as livestock feed ingredients include wheat middlings or wheat midds and screenings. There are 6 classes of wheat grown throughout the United States. These official classes are divided by its hardness, either soft or hard, color of its kernels, white or red, and its planting time, winter or spring. Each class has its own unique characteristics. For example, soft white wheat has a lower protein content and is used for cakes and pastries, while hard red spring wheat has the highest protein content and is used for breads. Meanwhile, durum is the hardest of all wheat varieties and provides the semolina for pasta production. Of the 6 wheat classes, soft white wheat is produced in the Pacific Northwest, here in blue dots. Soft red winter wheat is grown in the East, in brown dots. Hard red winter wheat is planted in the Great Plains, on our map in green dots. Hard white wheat is produced in California, Idaho, Kansas, and Montana. And hard red spring wheat and durum is harvested in the northern plains. Hard red spring wheat and soft red winter wheat are the most likely of the whole grain forms to be used as an ingredient in animal feed. The wheat milling process is quite complicated and could be an entire course in and of itself. In the abridged version, wheat is cleaned and tempered, then ground, sifted, and purified to produce flour. The various byproducts produced from this flour milling process are the primary animal feed ingredients derived from wheat. Once wheat is purchased from producers, it is stored in elevators prior to milling. Chemists inspect and classify the wheat using official U.S. grain grading standards approved by the USDA Grain Inspection, Packers, and Stockers Administration. Then wheat is cleaned to remove non-wheat material such as sticks, straw, stones, and insects, as well as to remove wheat that is not fit for milling due to it being broken, damaged, or small. The receiving separator has multiple passes to remove large contaminants on the top deck, smaller debris on the sand screen, and light debris in the aspirator section. Color sorting then uses digital cameras to evaluate color imperfections and remove rejected wheat and foreign material with a short blast of air so that only cleaned, color-sorted kernels remain. Cleaned wheat is then conditioned to prepare it for the milling process. Water, steam, or heat is applied to the wheat and then rested during a period called tempering. This step allows water to penetrate in the inner endosperm, which contains the flour, so that it softens and can be ground more easily. Tempering also softens the bran, which is the term, to make the bran more pliable so it is more resistant to breaking during the milling process. After tempering, wheat is ground through a roller mill, where two rolls are turning toward one another. Each set of rolls has different groove cuts, called corrugations, different numbers of corrugations, called pitch, and different pattern of corrugations, called spiral. Each of these changes causes a slight change in the grinding action, which loosens the bran from the endosperm or grinds the endosperm into finer particles. After each set of rolls, the material is sifted to collect similar-sized particles. These sifters contain a stack of sieves covered in woven mesh made of stainless steel or nylon called bolting cloth. The screening sizes get smaller from top to bottom, and material on the upper screens is reground. The material that gets caught on the bolting cloth sieves is called overs and needs to be reground. Meanwhile, material that flows through the bolting cloth openings is called throughs and is finished flour. The sifting process is followed by purification, where gentle agitation and upward airflow separates the desired endosperm from bran particles and other impurities, which is important for creating various grades of flour. While the wheat milling process is generally focused to make food-grade flour, there are a variety of wheat byproducts from the process that are common ingredients in animal diets. Wheat screenings are a byproduct of the cleaning process and are literally the products off the screens of the receiving separator. Screenings are divided into large, small, and light screenings, which come off the top deck, sand screen, and aspiration area, respectively. Large screenings usually contain corn, soybeans, stems, and non-grain material. Magnets are important to minimize potential metal physical hazards. Small screenings contain broken and small wheat kernels, small grains other than wheat such as sorghum, weed seeds, and small non-grain material such as sand and small stones. Meanwhile, light screenings contain light chaff, hulls, dust, stems, and potentially diseased kernels due to scab or vomitoxin. The bran and up to 30% residual endosperm contained within it is a byproduct of the grinding step called wheat middlings or wheat midds. Because the quantity of residual endosperm can vary widely, it is important to purchase wheat midds with a guaranteed minimum analysis. Germ and red dog are also potential wheat processing byproducts, but are less common to the animal feed industry than screenings or midds. The germ is undeveloped embryo of the wheat kernel, rich in fat and protein, and usually is too expensive to use in animal diets. Meanwhile, red dog are the overs on the last sieve of the flour milling process. It is sometimes used as a pellet binder in animal diets, but is more often used in the pet food industry. Food safety hazards are broken into 3 categories: physical, chemical, and microbial hazards. Overall, wheat possesses a very low risk in any single area. During cultivation, wheat may be exposed to agrochemicals or pesticides. However, there is little to no residue left prior to processing. Potentially, there may be physical hazards that come in with the grain during harvest. However, these are largely mitigated by magnets. Chlorine is often added to control microbial growth during the tempering process, and thus careful monitoring of these levels is necessary to control chemical hazards. Finally, cool, wet weather conditions early in the growing season can cause Fusarium graminearum mold growth, which can produce the mycotoxin deoxynivalenol, more commonly known as vomitoxin. Unlike aflatoxin, vomitoxin cannot pass through milk or tissues to humans, so it is a potential health and production threat to animals, but not to humans. In summary, we have shown that prior to reaching the feed mill, wheat is processed by cleaning, tempering, grinding, sifting, and purification. The 6 classes of wheat are soft white, soft red winter, hard red winter, hard white, hard red spring, and durum. The most common wheat byproducts are wheat screenings and wheat middlings. Potential feed safety hazards with wheat or wheat byproducts include non-grain material, pesticides, chlorine, or vomitoxin. And receiving separators, roller mills, sifters, and purifiers are important equipment in the wheat processing industry. This course was made possible by funding in part by the Food and Drug Administration through a grant to Iowa State University and Kansas State University. Thank you.